Hello and welcome to this section, Data in a Docker Container. In the previous section, we saw how to manage and monitor Docker containers without entering inside the container. In this section, we'll cover the data in a Docker container and the persistence aspect of it. In this section, we will have these topics related to data and persistence. First, we'll start with persistent data, where we will see what is persistent data and the default behavior of data in Docker containers. Next, we'll see volumes and mounting, creating data volumes and mounting of volumes from local machine to a Docker container will be covered in here. Then shared volumes. In here, we will take a look at the shared volumes concept of Docker. And next is backup, restore or migrate data volumes. Here we'll see the various ways of managing data volumes, including backup, restore and delete. After quickly summarizing this section, we'll have an interesting quiz at the end. Make sure you try this out. What is persistent data? One key property of Dockerization or containerization is that the containers are disposable and the data in it is transient or temporary. A container can be spun up in milliseconds, use it just as long as necessary, and then terminate with the minimum overhead on the system resources. That is, they are spun up to manage a particular demand or workload. And this transient nature also applies to the data within the container itself. This deletion of all its data within a container on its removal represents a major problem for running applications like databases, where availability of this data is essential rather than desirable. Availability of data even after the process with which it was created has ended is called persistence, and such data are called persistent data. In case of Docker, there are various ways to accomplish data persistence across the lifetime of a container. These are data volumes, mounting a host directory, data volume containers, mounting a shared storage volume. We will be looking into these in detail in the upcoming videos. Before that, first let's understand what happens to a container by default without using any persistence techniques. Okay, to understand the data behavior, we'll be using these commands. That is, we'll start a container and create a sample.txt file and then exit from the container. Okay, demo time. Let's create a container named non-persistent Ubuntu using the Ubuntu image. That is docker space run space -ti space -- name non-persistent Ubuntu space Ubuntu, which is the image name. Okay, we are inside the container. Let's create a new file called sample.txt with some text in it. That is echo sample text file within double quotes greater than sign sample.txt. Let's list and see the file. Now, using the cat command, let's confirm that the file is created successfully with its data. That is cat space sample.txt. As you can see, the file is created successfully. Now let's exit this container. As we can see in the docker space ps, now the container is no longer running and the file that we created is within that container. Now if you want to retrieve the contents of that file from the container, it is possible at this stage. This is possible only because we have stopped the container and not deleted it or removed it. We can confirm that the container is still present in the history by typing docker space -pl space -a or -l to see the last container that was stopped. -a will display all the containers. Yes, our container is present in docker space -ps space -l. There are two ways in which we can access the file that we created inside this container. Let's explore them. The first way is to restart the container using the docker start command, and using the exec command enter the container and access the contents of the file directly from inside the container. Okay, let's try the first method. Docker space start space non-persistent Ubuntu, which is the container's name. Then let's get inside, that is docker space exec space -ti space non-persistent Ubuntu / bin bash. Okay, we are inside. Let's list the file using ls-l space sample.txt and also cat the file. Yes, the file is still there. So this is the first way where we get inside the container. Now the second way is to retrieve the file using the copy command or the cp command. This command is used to copy files or folders between a Docker container and the local file system. The format used to copy files from a container to the local file system is docker space cp space container name absolute path of the source file or the folder followed by the file system destination path. Okay, let's try this out. This is the second method to gain access to the file. Let us list our current host directory to confirm that it is empty. In our example, we can copy the sample.txt file from the container to the current folder in the local file system using the command docker space cp space non-existent Ubuntu, which is the container's name, /sample.txt. That is the path of this file in the container, space dot or / to indicate where you want this file to be copied. The last parameter can also be a path to any other location within the host system. Let us see if the file has been copied to a host folder from the container. Let's list it. Yes, it has been copied. So the container from which we copied the file is presently running, as we can see from the docker space ps command. What if we stop this container and try to copy? Will it work? Let's test it. First, we'll stop the container, that is docker space stop space non-persistent Ubuntu. Let's now delete the host file sample.txt we just copied and confirm that the folder is empty. And let's repeat the copy command. Yes, the file has been copied from a stopped container. This is important to note. There can be situations when a container has exited and you may want to access the log files or config files within such a container, and this command can come handy. So what we have done is we were able to copy the contents of a container which is not removed to the local file system. These are the two ways in which we can access the contents of a container as long as it is not removed. As we mentioned earlier, the docker cp command can be used to copy files or folders between container and local file system. Now we can see how to copy files or folder from local file system to the container. The format is docker cp the local file system source path space the container name and the path to the folder or the file within the container. Let's try this. Let's create a file, say local.txt in our local folder. That is echo created from local file system within double quotes greater than local.txt. Now we'll copy this file into the container's root folder. That is docker cp local.txt space non-persistent Ubuntu : Remember that this command can be executed on a running or a stopped container. Now let's enter inside the container and confirm that the file has been copied. In our case, we had stopped this container earlier, so let's start it. That is docker start non-persistent Ubuntu and then docker exec -ti non-persistent Ubuntu /bin /bash. Let's first list the txt files, that is ls space -l space star.txt. Yes, there is our local.txt file. Let's cat and confirm that it is the same file, that is cat space local.txt? Yes, it is. So this is how we can copy files from folders to a container from the local machine. As we mentioned earlier, once you remove a container, there is no way you can retrieve or reuse the files or folders that we create inside the container. That is, the data in such cases is called non-persistent data. In the following videos, we'll see how to overcome this and make the data persistent. In this video, we learned about the persistence of data, the default data behavior of Docker containers, and how to copy data between the host machine and containers.